I'm Amy Gates. I am the director of our almost-to-be data science and analytics program. We recently changed the name to something that makes sense, because seriously, what does analytics mean? So data science and analytics. It's an absolute pleasure to be here. It's a pleasure to host this. It was a lot of fun. This entire group is awesome. Thank you to Jared. Thank you to Mark for inviting me the first time learning about this. And thank you to Heather Connor for working her butt off to make this happen. And thank you to our students and our volunteers. Thank you guys for coming. All right, good stuff. So today we're going to talk about using NetworkD3. And we're going to use it in conjunction with Twitter mining, with association rule mining. But our goal is going to be to create an interactive network visualization. And so any of you who have used D3 in the past, you know that D3 is, well, it is a steep learning curve. You could spend months and end up with a bar graph, you know. So the good news about this is that NetworkD3 is a package that works in R. It's relatively easy to use, which is nice. So let's take a look. And I'm going to go ahead and, by the way, I just did this last summer. It was awesome. I had to put that out there. Okay. So why do we build networks? What are networks? They're graphs in a mathematical sense, and that makes them really robust because everything that's true about a network is true about a graph and vice versa, which means all the mathematics of graph theory can be integrated into analyzing, understanding, evaluating, and looking at networks. So we look at networks when we want to understand the relationship between things, any things. The challenge is, do we know if there's a relationship? Can we define that relationship? Do we understand what the relationship is that we're trying to visualize or analyze so that we can put that together? So in my talk last year at DCR, I went through the Twitter part and the association rule mining part of this a little bit. I'm going to fly through that part this time, but if you want a lot more on that, you can also look up last year's talk. This part, I'm going to take a lot of that, but we're going to focus it in on how to then apply that and visualize it interactively using NetworkD3. Okay, so why would you want to build a graph, though? What is the purpose of a network? And generally, so a network is considered an abstraction. Generally, you want to model things that are in some way relationships. What are the applications? They're limitless. Anytime you have a relationship that you're curious about. So the one that always comes to mind, and I feel a little guilty saying this, but it's true anyway, before the last election, there were two words that occurred together in tweets, possibly more than any other two words that are, you know, I'm not going to go there, but these two, does anyone know what these two words were? Does anyone remember? Two words. I'll give you a hint. The first one's email. Hillary Clinton. Hillary Clinton and email, and just Hillary or Clinton, because I said two words, they occurred together in so many tweets. You could build a word cloud of the whole web, and you'd see these two words, the gigantic. That told a story that we're now living in, right? It told an interesting story. So you can use networks to do all kinds of things. And that's everything from the spread of a virus to analyzing terrorist networks to electrical networks that are not for terrorists. So, what's a network? It's a graph. That's all a network is. It's made up of nodes and edges. The edges represent relationships. The nodes represent anything you want them to. That's the beauty of building a network. The hard part is figuring out what the relationship is and then formatting the data so that you can make it something that you can visualize, something you can analyze and understand. So basic graph theory, and let's go through this quickly so we can get to the good stuff. Graphs can be directed or undirected. There are many different ways to represent graphs. So humans look at graphs like this. Computers, they don't do this, right? They do things that are numeric. So one way to represent a graph is using an adjacency matrix. This matrix is that graph. They are one and the same. That's just the computer view. That's our view, which is, I think is kind of cool. Now for NetworkD3, it actually prefers something a little bit easier on the eyes. Something that looks more like this, where you define the edges, you define the nodes, and then you can apply the NetworkD3 object to create the network. Okay, so we're going to focus on NetworkD3, but I don't want you guys to think that that's the only way to do this. There are many different ways to create graphs and networks, and these are several of the options. And here are some decent links as far as looking further into NetworkD3 as well. Okay. Now we're going to Tarantino it. Who's familiar with Tarantino? Thank you, guys, seriously. And if you're not familiar with that either, you have two things now that you need to do when you leave here. Okay. These three visualizations were created by using an API to get Twitter data. Any hashtag you want. I used world news. All the code's there for that. Then we took that data because that data's a mess. How many people have scraped Twitter with an API? Okay. So when you scrape that, you can put it in some different formats, but you've got to clean it up. We also want to clean it up, and in this case, we want to put it in a transaction format so that we can run it through association rule mining. Why do that? Because we're looking to create a relationship between words in tweets. The question is, are there words in tweets that occur more often together, more often in general, this type of thing? That's what association rule mining can do for us. It can tell us the words that occur more commonly. We can then take that and make that the relationship, and then we can visualize it. So that's where we're headed with this. I did this with world news. So I just did hashtag world news, and I just put the Twitter out there to do its thing, grabbed the data, cleaned it up, did association rule mining on it, which we'll see, and visualized by three different options. So here's one. This is called the support. This is a NetworkD3 viz. It's interactive. This is on the web live, so it's wrapped up in an HTML wrapper, which I'll show you code for as well. This one's interesting because it created actually two disconnected components, which is kind of fun. And you can then see when I did the world news, there's obviously something was going on in Mexico. There's some intimations to drug, United States, cartels. That was one thing going on. World news was the hashtag, and so on and so forth. So this was one of them. The other one I did using confidence instead of support as a measure got some really different results, which makes this fun and makes it interesting to use association rule mining for this. Okay. So here's what's fun about NetworkD3. People like to play with it. You can play with it. You can explore it, you can look at it, you can ask yourself questions about it, like are there clusters? Are there families? What's the diameter? What's the node degree? And you can even integrate that into the NetworkD3 object as you wish. So, in the spirit of Tarantino, did you close my thing? It closed my thing. Why would it do that? Oh, no. Now I'm going to have to search for it while showing you guys my screen. I didn't put that picture myself up. Someone else did that. Okie dokie. There we go. That's fine. Okay, let's just go back right where we were and pretend that didn't happen. Okie dokie. Yeah. So, that's where we're headed. So let's get there. Yeah, sorry about that. It does that. Yeah, let's skip to the good stuff. So, a couple of measures that you can utilize when you're evaluating networks. You can use a measure called betweenness. And betweenness will give you a higher measure if the node has more of a communicatory effect to the other nodes in the network. So you can tell here that node 4, if you were to cut that node, you would actually disrupt communication maximally in this network. So that's interesting. It's interesting if you're trying to put a stop to a viral outbreak. It's interesting if you're trying to put a stop to a terrorist network. Right? Sometimes you care about betweenness in a graph or in a network. So that's one of the measures. One of the other measures that we see a lot is the notion of communities. So if you were to use Facebook data and create networks of Facebook data, you would discover that the relationship is who's friends with whom, and then you would see clusters of friends, and then you'd see connectors. Those connectors have the highest betweenness measure. And so that's interesting as well, depending on if you wanted to communicate or disseminate information. So network communities are also great interest when you're evaluating. And this was, there it is again, a terrorist network. And sometimes you'll ask the question, okay, we have a terrorist network and we're trying to take out one of the core elements. Which one should we take out first? Because every time we do something, it costs money and has questionable results. So we want to make sure that, we're at least picking the right one. Okay. So networking is everywhere, and it can be applied to pretty much anything, even biological systems. And so finally, let's get to the good stuff. Okay. So how do we do this in R, and what are the steps we're going to go through here? First of all, you need to get a Twitter developer account if you want to use my code. And you can run this code and get these slides. Once you get a Twitter dev account, you will get a bunch of keys and tokens and the name of your firstborn child. And you will use that information to essentially access Twitter. So what's kind of cool is that when Mark gave his talk, he talked about APIs. This is an API for Twitter. And in this case, we're accessing Twitter using the oath, using all the tokens that we get and so on. These are the libraries that I used. The ones in bold were directly used. The ones not in bold I played around with but left them because I think people appreciate that. Okay. So here's the build the environment part of this. This is where I set up the oath. So set up Twitter oath, sets up the API, and then the Twitter, and then search Twitter. And you'll notice I searched for world news. I gave it a date. I gave it the number of tweets. I pulled that search object into a data frame, and then I want to take a look at it just to make sure that I'm grabbing that first tweet. So the search, df, text. I feel like this should function. Where's the beeper thing? It's okay, you guys know what I'm talking about. Okay. Here's the text from the tweets. What you end up getting is a data frame. So this is one column of that data frame. There are other columns too, like geotags, like dates, like whether it was retweeted. There's a ton of information in every single tweet. This is part of it. Now, the trick of association rule mining in this case is you don't want to lose the tweet. This is not the same as bag of words for people who are familiar with that. I'm not taking all the words in every single tweet and just simply creating a vocabulary of words with frequencies. That's certainly one way to do it in text mining. What I want to do here is I want to keep each tweet. I don't want to lose that context. And I want to ask the question, what are people tweeting about most often in each given tweet? So that's an interesting question. Now I'm going to do this part fast because, again, this was done last year a little bit. So here's a single tweet. I can access it. Here's the part where I build the transaction data from the tweets. Here's what it starts to look like. So instead of now having tweets, I start to have individual words. It's still very dirty, and I have to clean it a lot. So here's all the cleaning bits. I'm not going to read you code, but it's there for later. Okay. Now I'm looking a little better. I still have things one tweet at a time, which is good. Once I have it in that state, I can read it in as a transaction data. So you'll notice that this is for my students too. This is not record data. Guys, I'm hoping you guys know this now. This is not record data. This is transaction data. Every row is a bunch of tokens in this case, which are words. So there's no columns per se which represent variables, and the rows can go on as long as you want them to. That's the difference between transaction versus record data. Okay. Once you have it, you can read it in, do some fancy footwork with using arules, the a priori method. This is all association rule mining in R. You can choose your support, your confidence, your lift if you wish, and things like this. And eventually you can sort the rules. Here's what we're trying to get to. So all that stuff, everything I just covered, that was a little bit of a review of last year. Here's what we're trying to get to. Because what we want to have is a relationship between words. We want to see that lives and world news are related to each other. We want to see that lives matter, are related to each other, things like this. Because we've now determined a relationship, now we can build a network. So you can't just plop record data into a network. It won't work. You have to determine what is the relationship you want to show or visualize. From here, and this is a 17-hour error, just in case you run into this with arules, this will fix it, just FYI. In this case, what we want to do now is we want to build the things we need for the NetworkD3 object. So NetworkD3 is going to expect things from us. It's going to want to know what are the nodes, what are their IDs, what are they called, what are the edges, which node goes to which node, How do we want to color them? How long do you want the edges to be? How fat do you want the edges to be? It wants to know all this information from us. So right now at this moment, like all of data science, we're going to spend 90% of our time formatting it and getting it ready, right? And then 5 seconds enjoying it, which reminds me of something else as well. Okay. Yeah. Thank you for that. Okay. So, somebody just got it over there. Okay. Converting our rules to a data frame is our first step. Once we have our rules in the data frame format, we can start altering that data frame to represent the edges that we need for NetworkD3 and the nodes that we're going to need for NetworkD3. So it's basically a process of massaging our data into the format that we need it to get into. Okay. So here's where we are now. This is a much better spot. We actually have a from node, a to node, and some kind of options for weights. Again, I won't have time to go into what support, confidence, and lift means. I wish I did. I did that last year. So if you're wondering, just watch that talk. And that's what I did that a lot. That was the whole focus of the talk. So now I just have to take my word for it. These are 3 different measures I can use to weight the edges. I can weight the nodes. I don't have to weight anything. It's really up to you what you want to do with your network. Okay. Now I'm finally going to build the edges. Because I use association rule mining, I have sort of 3 different sets of rules that are of interest. When you do association rule mining and you sort by support, you get a different set of associations than you do when you sort by confidence or when you sort by lift. So just as a quick example, support is how often words occur together in a data set. Confidence is how often they occur together. So it's going to give you some different results. So in this case, what I'm doing here in this code is I'm taking different columns out of that data set because I want to see all 3. I want to see what they look like. And I'm going to go one at a time. I don't have a loop here, so if you were to do this, you'd have to either unhashtag or put in a loop. And I'm going to then finally build the edge list. Now this is where understanding what an object expects is it's part of it. You have to do it. So in this case, NetworkD3 needs something called a node ID. It needs a source node. It needs a target node. And the IDs have to start at 0, whereas we know that R starts with 1. So we have to make a couple of adjustments so that we're, again, shifting our data over to what NetworkD3 is going to expect. And that's what all this does, essentially. And here's the result. So now I have a source name. That's one node. I have a target name. That's the node that it's going to. So now I have an edge between Americas and countries. I'm going to have an edge between Americas and experts, and so on and so forth. So this is essentially defining that edge list. I have a weight, and I have now source IDs and target IDs, which NetworkD3 requires. I need to build the nodes as well. I use iGraph, and then also used iGraph to update the IDs so that they were all subtracted by 1 so that NetworkD3 is happy. In the end, you end up with a nice node list. So this is the name of all the nodes, the degree. What is a node degree? It's how many edges are incident to that node. So we want that information too. And you can use that information to affect the size of the node if you want as well, which is interesting to look at, and so on and so forth. So what we've created now is we have a list of edges, or an edge list, and we have a list of nodes. So if you pause for a second, you think, where do we start? We started with the Twitter API. That's where we began. All we did was grab tweets, and then cleaning and formatting in DataFrame, and then building an edge list, defining a relationship, using association rule mining to create that relationship, all the way to a point where we have something like this now. In the past, when I've seen people talk about building networks, this is where they start. I feel like it leaves out all the part of what you have to do to get here. That's 90% of what you have to do. The rest of it's just a fun bit. So, here's the final part. This is the NetworkD3 object. To me, it's very, very exciting. So the object is made up of all kinds of attributes, right? We need to define the links, and we did that. We have an edge list. Those are the links or the edges. We need to define the nodes. We did that. We built a node list, so we're going to use that. We have a source, that's our source ID. We have a target, that's our target ID. We went through and actually built all of these things so that we could create this object. We have value equals weight, and you can set the weight to be the confidence, the lift, the support, or some function of those three. You have a lot of options there. And then finally, we can affect some of the other things. One more thing I'll note here. Oh my gosh, you guys, am I out of time?
Yeah.
Oops, my bad. Anyway, that's the object. I will note one more thing before I stop talking. You guys are giving me that look like you need to stop talking. So NetworkD3 it has a JavaScript option that allows you to pull in functionality from value and affect the length and width and so on of your nodes. This is how this works. So I'm done, and let's take a final look at just NetworkD3.